Okay. Good afternoon, Web Summit. Very happy to be here. So, thank you for being in this second half. My name is Luis from Woxsen University in India. I am a Venezuelan, Mexican, and Brazilian also. So, Necrobiotics. So let me ask you a question here. How many of you can raise your hands? How many of you will accept an eye surgery with a dead spider? Raise your hands. Raise your hands. Okay. So I understand it's probably science fiction, but it's not. We have been working in this with some other universities since a long time ago. We already have books and a lot of papers and scientific analysis and also a patent about this we call Necrobiotics. Necrobiotics is the integration of biology, computer science, and most important, biology. So, it is a breakthrough. It is something very different. But, as you can see here, it will be performing delicate eye surgeries, among other probably important interventions. The spider, you see it in your screen, is a gripper. It's an organic gripper. It's a dead spider with hydraulic legs mechanism, very well designed, connected to AI, a machine learning, to understand the memory muscles of spiders and understand how it will grip an object, for example, in the eye, or most importantly, if you have something in your eye like a glaucoma, it will come, it will put some medicine in your eye, and then it will remove it, that disease. So it's a necrobiotic gripper. Basically, we're talking here, lifting objects, utilizing materials also in this robotic for what? Medical advancements. We're talking about technology promises with precise and organic, this is important, surgical tools. We're talking about innovation, and yes, there is ethical implication in it, but this is an eco-friendly tool, an eco-friendly device, an organic device that we're going to use for healthcare. So, why a spider? If you can see here, what most of the medical procedures are doing right now is an invasive one, doing with metals, doing with plastics, things that will damage your eye. The spider is an organic. We have been testing the, let's say, the body of the spider, and we have been working with a lot of biology and also, let's say, mechanical engineering information to be more precise, to perform this robotics with a life-saving operation. We're redefining definitely what robotics and biology intersected. I understand that this is something disruptive, but it's real. We are performing it, not only in some, let's say, environment to perform the algorithm of this, but we are also doing some testing. So, beyond the human hands, the eye surgery will perform with the information that biology provides from the spider. You can see here the three most important steps for this procedure. First one is the euthanized spider. This is a complicated procedure with a lot of investments to provide, let's say, the proper environment to euthanize the spiders, as many as you may need for this kind of, let's say, procedures when will be massive, all right? Second is we provide into the dead spider body, we provide a needle, and then we put some glue, and there's going to be the hydraulic process. So we inject water, and the spider or the organic gripper will move the legs with AI and machine learning thinking which kind of legs are going to move depending on the operation you're going to use. So technically, we're talking about biohybrid system, hydraulic architectures. We are actually action in soft robotics. Definitely we're talking about necromechanical interfaces here, micromanipulations, precise, and predictivity movements, because this is let's say we are prototyping this, commercializing already, but the predictivity using AI and machine learning is very important. So not only will bring a real possibility for healthcare, but for nano IoT technology for another procedures. Okay, so what if we could make machines to move like biological creatures? So the spider that you will see here, the dead spider, it has the characteristic that can lift its own weight. So can lift another spider. So force and physical force is testing also. We're not talking just about robotics here. We're talking about rethinking biology, the intersection with biology, computer science, and robotics. So dead organism like a spider, and probably you can use with worms in your stomach, or scorpions, has creating robots blurring the lines between life and machine. What we're doing? We're intersecting three important, let's say, topics here. We're talking about biology. When we're talking about biology, we're talking about autonomy, physiology, biochemistry. Most important, the ethical considerations in the biology. About the robotics, we are talking about engineering, mechanical engineering, functionality of the robotics, programming algorithm, digital transformation, hardware, prototyping, and finally, computer science, using machine learning, data analysis, software development, and some other tools. And we combine it, we call Necrobiotic system, and there is, yes, an ethical consideration implied. Well, you can see here our product that we are deploying. This is a software in Phantom in which the charter number 1 is a spider. You can check the legs. It's picking a red object from the eyeball, right? So we are simulating how, in this case, the 2 legs are going to remove the object that you probably will have in your eye or a glaucoma and put the object outside your bull eye, and they can use the grip of the spider, can use the 8 legs or 2 legs only. So we are simulating this. This is something that we are doing some practical testing. It's not something that it is just in a prototype. We are created, and this is very important you to listen, the most realistic environment for testing. Meaning that with this experiment, we are doing the framework for other similar experiments that will come in the future. Everything is about adjustment and do, creations before to go to the real life production. So testing and simulation will be very important. We have been trying this, and now we are doing with the real spiders with some institutions in India. We have been also working with some universities in the United States and other countries to see the feasibility to approve this, to put it into the market, because we understand that ethical considerations is important. So, challenges for necrobotics in healthcare in general, we're looking for precision and accuracy. That's what we need when we're looking for our health. And technology is going to bring us that. Customized organ fabrication is something that is not new, right? It's something that has been there like for a couple of years. But now, with the precision and the predictivity of the digital transformation like AI, we're making it possible. Neuroresponsive prosthetics also, it's in the way of healthcare improvement. We're talking about smart drug delivery system. Smart, specific, something that we can put together using the technology and using what we have right now. And finally, biometric diagnostics, for example, among other important events. So, this is a moment, and I understand probably your faces that I'm seeing right now, probably surprised, but this is real because we are crossing some lines between biology, robotics, and we need to ask ourselves, what are the ethical implications in this? So, innovation must be grounded and must be debated as a responsibility right now. Not only innovation itself for creativity, new tools, but which are the ethical, let's say, impacts that technologies like this will bring to us. There's also a lot of legal and cultural challenges and regulations in a lot of places, like India, for example, in where I live. Animals and some other creatures and objects are protected to use it. So it's not just how we have the culture and the regulations with the technology, which is the really frontier of the innovation, which is the real frontier. If you can imagine a dead spider saving your eye for blindness, for example, going to your retina and trying to save your retina from a glaucoma, for example. It's something that we need to think. It's about ourselves. It's about using what we have, which is nature, technology, and physics. Okay? So the next steps in our project and for us is to make this transition for more complex system, not only using spiders, but probably worms, as I said, or scorpions, and with the testing that we have, begin to make this possible and save lives. And go to the eyeballs, for example. This is what we're testing, but we can do it with other organs as well. Designing more interactions. This simulation, it is still, right now, in this time, in this very moment in India, it's almost 8 hours of difference. We're simulating this. This is now stopping simulator because we need to understand exactly how it's going to work when applied, when the regulation allows in some countries to go through some medical procedure. We need to ensure real-life work functionality. This is very important. How AI is going to integrate it with driving decision, right? Not only making some layers to make decisions, but how the medical sector, the healthcare sector, and other, let's say, institutions, we will see this incredible and innovation procedures with dead spiders. We need to build partnerships. Okay, that's what we're here, trying to build partnership with the universities, private sectors, governments, to understand and to provide this as a massive solution, meaning that we need to redefine the data collection and have the feedback to improve this. And most important, and I will say this is one of the most critical, and believe me, we are working so hard in this topic, the regulatory framework and the ethical conscious and work we need to do in the future and now to put this into the work. So thank you so much to allow us to present here. You're always welcome to our university. We are in India, in the state of Telangana. It's in the middle of India. The city is called Hyderabad. We are like about 2 hours from Hyderabad. You can always come there, visit us. This is my information. I hope you guys have a great event and let us know any questions. Thank you so much.